Day 352 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 378, kth smallest element in a sorted matrix. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go on and check out that link in the description so you can get you some. Now let's see what the question says. Given the n by n matrix where each of the rows and columns is sorted in ascending order, return the kth smallest element in the matrix. Note that it is the kth smallest element in the sorted order, not the kth distinct element. You must find a solution with the memory complexity better than big O of n squared. All right, y'all, sounds simple enough, but let's just go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input equals or matrix equals a n by n matrix or 2D array, first array or first row being 1, 5, 9, second row being 10, 11, 13, third row being 12, 13, 15, k equals 8. Right, so we can already see that these rows are sorted in ascending order, and we want to find the eighth largest element in that ascending order. And the output says it's 13. Explanation says the elements in the matrix are 1, 5, 9, 11, 12, 13, 13, and 15, and the eighth largest number is 13. So let's go through this because actually it's not completely sorted in ascending order already, because as you can see there's 13 here in this row, and then we go 12, 13, 15 in this row. But when we sort all of them, we go 1, 5, 9, 10, 11, 12, 13, 13, 15. So we see that 13 and k equals 8. So we see that goes 1, 2, 3, 4, 5, 6, 7, 8. So once all of the elements are sorted in ascending order, that's when we see that 8 or that 13 is the eighth largest, and we want the eighth largest because k equals 8. If k equals 7, we would want the seventh largest. So let's go ahead and take a look at example 2, where it's a little bit easier because there's only one element. So in example 2, we have our matrix equals our n by n matrix, -5, k equals 1. Output is -5 because there's only one element in this matrix and k equals 1. So we just have to return that one element, which is -5. All right, y'all, that sounds simple enough, but let's go ahead and get into the fun part, the actual solution. The solution is not going to be that difficult. We want to do it in a certain amount of memory complexity, so we're going to use a binary search for that. So yeah, let's get started. Now, the first thing we want to do is we want to create an edge case. So if the matrix is empty, we could just return -1. So we're going to use a guard statement for that. We're going to say guard exclamation point matrix dot is empty. So this exclamation point means it's not empty. So guard matrix is not empty is what it's really saying. Then we're going to say else. If it is empty, then we could just return -1, just like that. Boom. Then we need to define the search range with the smallest and largest elements in the matrix. So we're going to declare a variable called left, and we're going to set that equal to matrix square bracket 0, square bracket 0. Then we're going to declare another variable called right, and we're going to set that equal to matrix square bracket matrix dot count -1. Then we're going to come outside of that square bracket, and we're going to say matrix square bracket 0 dot count -1. Oh, sorry, y'all. This should be in another square bracket, -1. Boom. So this should be in its own square bracket as well, and this should be in its own square bracket. Boom. Now we're going to create a helper function which is going to help us count how many numbers are less than or equal to our, we're going to create a limit, we're going to pass in our limit, and the limit is just going to be help us count how many elements are in the matrix less than that limit. So if the count is less than k, then we know that the k smallest element will be larger than the limit. So that's what our helper function is going to help us do. So we could just say func, we call it count, we call it count of numbers. Then we're going to open up the parentheses, we're going to say underscore, and we are going to, it's going to have a limit, and the limit is going to be an array of, or excuse me, not an array of integers, but the limit is going to be an integer. And then it's going to return an integer like that. Then we're going to open up the brackets. Then we're going to declare a variable called count. We can set that equal to 0. Then we're going to declare a variable called row, and we can set that equal to 0 as well. Then we're going to say comma, and we'll have one for column, so we'll say COL, and we'll make that equal to matrix square bracket 0 dot count minus 1. Boom. Now it's time to go through the matrix. So we're going to say while row is less than matrix dot count and two and signs, call is greater than or equal to 0. We're going to open up our bracket, and we're going to say if matrix square bracket row, come outside that square bracket call is less than or equal to the limit. We're going to open up the brackets, regular brackets, and if the current value is less than or equal, or excuse me, is less than the limit, all the elements in this row up to call are going to be less than the limit. So we're going to say row plus equals 1, and we're going to say count plus equals call plus 1. Boom. Then we're going to come right here, and we're going to say else, open up the bracket. If the current value is greater than the limit, we're going to move left in the same row. So we're going to say call minus equals 1, just like that. Then we're going to come down here, and we are just going to say return count. Boom. Now we're going to start our binary search over the value range in the matrix. So we're going to come right here outside of this function, and we're going to say while left is less than right. We're going to open up the brackets. Then we're going to say, we're going to find our mid by saying let mid equal left plus, open up the parentheses, right minus left, and we're going to come outside of that, and we're going to divide that by 2, and that's going to prevent any overflow for us. Now, if there are fewer than k numbers less than mid, then we can discard the left half, right? So we're going to say if count of numbers, open up the parentheses, mid, pass in mid, because that's what our limit is going to be up here. The limit right now, the limit is mid, so we're going to say if count of numbers, we're going to pass in mid, is less, excuse me, y'all, I don't know what's going on. Whoa, let's see, my bad, y'all. Pass in mid is less than k. Then we're going to open up some brackets, and we're going to say left equals mid plus 1. Boom. Then else, otherwise we can continue searching in the left half. inclusive of mid. So we're going to come right here and we're going to say else right equals mid. Boom. Now we're not done yet because we still need to return the kth largest element. So we're going to say, we're going to come right here and we could just say return left, because left will end up being the kth smallest element after our binary search. So let's go ahead and run it. Make sure it runs properly before we submit it. Ooh, look at that, first try. So let's go ahead and submit it now. See what happens after we submit it. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I'm talking about. That's what I like to see. Those are some good numbers right there. So with that being said, before we leave, y'all, make sure you get one more look at the code. This is the top half. Boom. This is the bottom half. Read it, learn it, love it, internalize it, do what you got to do so you understand what's going on. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.